in this episode of Idea City.
June 28th, 2011, and we are getting our very first data from the Pluto system taken by the Hubble cameras. What you see is Pluto there in the middle, Charon is off to the lower left, and then, of course, there are stars.
So as we're moving out in the solar system, we now come to a grizzled old astronomer, Mark Showalter, the real thing, the man who discovered moons of Pluto. And after you're through with your dissertation, perhaps you'll tell me why Pluto was downgraded. An emotional favorite of mine.
I feel the same way, yes.
Mark Showalter.
Thank you. In 2009, I was talking all about the research I've been doing with the rings and small moons of Saturn. So let me give you a very quick recap of my talk. The basic gist of it, you get that? All right. The basic gist of it was that although there are very many exotic phenomena that we see in the rings of Saturn, actually most of them can be understood in terms of very, very straightforward physics. I actually ended with this classic shot of the Saturn system. In that little square upper left, there's a little dot. I hope you can see it. That happens to be us. That's planet Earth. This is an image that was taken with Cassini looking back from the far side of Saturn toward the center of the solar system with the Earth there just off the tip of the rings of Saturn. Classic shot. By the way, in about a month, everybody, I think it's July 19th, everybody in Toronto needs to go outside at about 7:30 p.m., look towards Saturn and wave, because Cassini is going to be repeating this image for one last time. And if you want to be in it, you get the opportunity. But today I'm actually going to talk about that big fuzzy blue ring that's outside of everything else. That's called the E-ring. And let's zoom in on it a little bit. There's actually a dot. Maybe you can see it at left. And if we zoom in, it's Enceladus. It's a tiny moon of Saturn, relatively small. It's very unusual, though, in that it has plumes, kind of like geysers, that are sending this spray of ice crystals out into orbit. Now, those crystals don't stay in the orbit around Enceladus, but they spread out and stay in an orbit around the Saturn itself. So that gives rise to this beautiful, broad, fuzzy E-ring that you see. The recurring theme out of this is that small satellites often create rings. That's a rule we've discovered in our studies of the outer planets. And so, for example, here's another example, Anthe. It's only a 1-kilometer moon of Saturn, but there you can see this delicate arc of dust that is coming off of it as it spreads out around Saturn. So that's what led us to thinking about Pluto, because a few years earlier, Nix and Hydra, 2 small moons of Pluto, had been discovered. Here you can see them in their Hubble discovery image. Pluto is the largest one. Charon is to lower right. That's a very, very large moon of Pluto, almost half as big as Pluto itself. And then Nix and Hydra, these little dots. So other people having discovered Nix and Hydra, it crossed our mind that this was not such a ridiculous idea anymore. So we had an idea about how to get some time on the Hubble telescope, take a look, and see what might be there in terms of a very faint ring in the orbits of Nix or Hydra. So we wrote up that proposal. We were very proud of it. We hit the send button. We waited a little while for the reply, and here it is. Dear Mark, we regret to inform you that. Anybody else ever get a letter that started this way? Okay. Kind of sucks, doesn't it? But it actually gets worse there at the bottom. It says, your proposal was graded in the 4th quartile of proposals in your panel. I mean, that kind of hurts, I got to say. By rights, any story should have ended right there. But there is a spacecraft on its way to Pluto. It's called New Horizons. It was launched a few years ago. It's getting there just about 2 years from now, July 2015. The team of scientists that's managing that spacecraft was very curious about whether they might encounter something like this. And so they were aware of our proposal, and all I can say is that there were back-channel communications going on between management of one mission and management of the Hubble, and the next thing we knew, our humble 4th quartile proposal was being scheduled on the telescope. Don't plan on this happening anytime soon. Even though we did not find any rings, we in fact started to think, if there's a P4 out there, what about a P5? What else might be going on at Pluto that we don't know about?
Get the latest Idealist news, presenter information, and watch streaming video at ideacityonline.com.
So here we are. It's June 28th, 2011, and we are getting our very first data from the Pluto system taken by the Hubble cameras. What you see is Pluto there in the middle, Charon is off to the lower left, and then, of course, there are stars. Stars are streaming behind the system, and they make analysis of this, especially when we're looking for something very faint, rather difficult. But let me show you one of my tricks for dealing with situations such as this. I'm going to stop the action on this movie now. Let's think of it not so much as a movie as just a stack of images. And so let me turn that stack on its side so maybe you'll get a sense of what I'm talking about. Now, inside the computer, I can do whatever I want with images. I can add, multiply, any kind of mathematical operation. The one I decided to apply was sort. I'm going to say, if you are a bright pixel, go up. If you are a dark pixel, go down. And so we transform this stack into this stack. All right, let's go back now and look at the top. You may not think I've done myself any favor. This is kind of a mess. But in fact, let's start peeling off the top layers of that stack. And you see they actually clean up very, very nicely. And so once you get a few layers down, it becomes, in fact, incredibly easy to see Nix and Hydra, those two newly discovered moons. Now, does anybody see something else out there? Just curious? I'll draw a little yellow circle. We had realized, and since we were doing longer exposures of Pluto than anyone else had ever tried, we had a chance that if there was a small moon out there, we might see it. And in fact, this looked very suspicious to me. So a few days later, we were getting more data from Pluto. That same little dot showed up again. It had moved by just about the right amount to be an object in orbit around Pluto. And that was the discovery of what we're calling P4. This was the NASA press release that came out just a few days later. Well, in fact, I've been involved in discoveries of a couple of other moons, a couple of other rings. They get a little bit of a press attention, you know, a little splash, and that's kind of fun. I was not the least bit prepared for what came next, because the internet just went crazy. Especially everybody wanted to know, what's the name of this thing? Here we have the International Business Times, of all things, debating the relative merits of whether we should name it Mickey or Cerberus. You know, I'm pretty sure this is the first time the names Mickey and Cerberus ever showed up in a headline anywhere. So this was really exciting for me. The trouble is we had bigger fish to fry on the New Horizons team because this raised an issue for us, and so we had to table this whole naming issue for just a little while. Come 2015, we have a spacecraft that's going plunging through that system at 14 kilometers per second. Pretty fast. A tiny grain of sand would be enough to knock out the one instrument or maybe even render the entire spacecraft inoperable. So we really need to know what's going on at Pluto. Even though we did not find any rings, we in fact started to think, if there's a P4 out there, what about a P5? What else might be going on at Pluto that we don't know about? And that kind of shattered our confidence, and we decided we really need to know the system better. So we went back to the Hubble Institute, and we said, we need more time. We need to take a closer look at Pluto. And they were very, very generous. And so this is basically a calendar of how I spent my summer vacation. We got about 50 hours on the telescope last June and July. It was a tremendous, tremendous thing they did for us. And on June 9th, I took a look at the new data. Nothing interesting showed up. Unlike most Hubble programs, we were actually hoping that nothing interesting would show up in our data. June 11th lived down to or up to our expectations, nothing new. And on through June, and then into July. So you can imagine by the time it rolled around to Saturday, July 7th, I really didn't feel like spending my beautiful Saturday afternoon looking at new Hubble data. But, you know, I am a geek, and it is my job, so I went ahead and downloaded the data, ran it through my pipeline of data processing techniques, And this is what came out the other end. So what you see here are 3 sequential images of the Pluto system. Each of these is a 30-minute exposure now. It's a very, very long exposure. By doing 3, and they're separated by about 90 minutes each, you can see a little bit of motion. You can see Nix and Hydra wobbling, and P4 off to the right wobbling. That we did because we would know for sure if we saw something that it was actually in orbit around Pluto. Now, maybe, I hope everybody in the room can see that I was rather struck by something going on in this image. It's right there. That's not supposed to be there. We didn't know that was going to be there. And that was actually the discovery of P5 just last summer. Something very large hit Pluto early in its history, but most of that stuff that comes off of Pluto stays in orbit around Pluto. And you can imagine that over time, that big stuff would all coalesce to make a big moon like Charon.
Get the latest Idea City news instantly. Follow us on Twitter.
Raises the question, why hadn't we seen it earlier? Kind of embarrassing answer, but I'll just say that P5 was a very sneaky moon. It's on an orbit that's very similar to that of Nix, which of course is much brighter here. And during most of the month of June, it was just passing. It was basically catching up on Nix from behind. For our purposes, we were always looking at these images, and we didn't see it because it was right next to something much brighter, but it was there all along. There's a moral in there somewhere, but anyway, sometimes it's good to be humbled a little bit, no matter what field you're in. All right, so that was then came the NASA press release, and this is now the system of Pluto as we know it today. So Pluto and Charon are in the middle, 2 large objects that act as a sort of a binary planet, and then we have these 4 neatly nested moons around them. And raises the important question of how did a system like this ever come to exist? So we've made some progress on that. I want to show you an animation, or actually a computer simulation, done by my colleague Robin Knupp. She works at the Southwest Research Institute in Colorado. And she basically says, and I think most of us agree now, something very large hit Pluto early in its history. And if you watch what's happening, it makes a big mess. First of all, that's very clear. But most of that stuff that comes off of Pluto stays in orbit around Pluto. And in fact, you can see sometimes there are big lumps going by. Sometimes this stuff, with its own gravity, is pulling itself together and forming larger objects, like that one. And you can imagine that over time, that big stuff would all coalesce to make a big moon like Charon. And that maybe some of the debris that was left behind would make Nix and Hydra and so on. So that sounds very plausible, and it seems to make perfect sense, except I just totally lied to every one of you. This simulation has nothing whatsoever to do with Pluto. This is actually a simulation of how the Earth and the Moon came to exist. The fact is that very early in the Earth's history, something large hit it, and that's how the Moon came to be. The Moon's a bit smaller relative to Earth than Charon is, but it's kind of like another binary planet. There are 2 binary planets in our solar system. There's another difference, though, when you look at them today. The Earth and the Moon are not very close together. People don't always appreciate quite how far away the Moon is. If you wonder why there are so many asteroids that are easier to get to than the Moon, that's why. All right, let's compare that now to the Pluto system. What I've done is I've scaled up the Pluto system so that Pluto and Earth are the same size. So there's Charon, which is in much closer than the Moon is, you'll notice, and then those 4 little moons lined up outside of it. There's a reason for that, though, which is that the Moon has been spiraling away from us very, very slowly. We have a big ocean. That ocean has water sloshing around. The Moon raises tides, and that causes the Moon to spiral outward. The Moon is moving away from us, even today, 3.8 centimeters per year, something like that. Put another way, the Moon is moving away from the Earth about as fast as our fingernails grow. It's something to think about. But so if you play this backwards, then think 1, 2, 3, 4 billion years ago, perhaps when the impact happened, these 2 systems were actually very, very similar. And so we can also speculate a little bit What if Earth, one day in the distant past, had its own little Nixes and Hydras floating around out there beyond our very much bigger moon? It's quite possible, because they would have basically been swallowed up by the moon as it evolved outward. So what we see when we look at Pluto is essentially a moment early in the Earth's history, frozen in time. So it kind of gives you a reason to have a little more respect for that distant dwarf planet, doesn't it? William Shatner, Mr. Captain Kirk himself, did this tweet when he heard about our poll. So what do you think about the naming of the two moons, Pluto, Vulcan, and Romulus? They have mythology, positive and negative.
Great ideas are meant to be shared. Join the discussion on Facebook.
Astronomical Union, or IAU, sets the rules for how we name the moons of the planets, and in this case, the dwarf planet Pluto. Satellites in the Plutonian system are named for characters and creatures in the myths surrounding Pluto and the classical Greek and Roman underworld. The minions of Hades. That is a very colorful cast of characters, and I think that's part of the reason why the public has taken so much interest in the naming of these little guys. So we decided it was not fair for us as a discovery team to name them ourselves, and we opened that up to a kind of a crowdsourcing, something a little different. We set up a website, plutorocks.seti.org, back in February. By the way, this was all done with Google Docs. We knew full well that if people were going to be voting, the SETI server would be brought down in an instant. So with the help of Google, we set it all up. We seeded the list with a few of our favorites, names that we thought would be compliant with the rules and that might be popular. And we got about 500,000 votes coming out of this thing, which was kind of gratifying. Actually, about half from outside the United States. They came in from all over the world. We also had a write-in ballot, because we realized that we might not have come up with the best names for these moons. And that turned out to be a very interesting experience. We had 30,000 write-in candidates. I won't say that we actually read all the nominations. But here's a just quick overview. Of course, the #1 write-in names were Mickey and Minnie. That doesn't really require explanation. But you can scroll down this list, and it's got it ranges from the sublime to the ridiculous. There are some ideas out of Star Wars and Star Trek and your favorite movies. But then there are also some very, very thoughtful ones. I would swear a few people actually took their entire doctoral dissertation and posted it in that little box that said, explain this recommendation. It was fascinating. That 30,000 people across the world would really give this some thought was just astonishing to me and really exciting. And we did actually, in fact, update our ballot based on a subset of the names that were showing up repeatedly. That all got eclipsed by one tweet, however. Someone we probably all know, William Shatner, Mr. Captain Kirk himself, did this tweet when he heard about our poll. And it was, at first we thought, a frivolous idea. So what do you think about the naming of the two moons, Pluto, Vulcan, and Romulus? They have mythology, positive and negative. You know, we've been seeing cartoon characters and everything else on the list, but then we stopped to think, you know, Vulcan and Romulus, they are actually Roman gods. So they might be compliant names. Now, we had to disqualify Romulus because it's already been used as one name of a moon of an asteroid. But Vulcan seemed to be compliant, at least it might be, so we put it on the ballot, and here's our final summary of votes with Vulcan way out in the lead. Cerberus came in second, and Styx came in third. Now I'm about to disappoint everybody in the room, because I do not yet know what the official names of the moons of Pluto are. There's been a deliberation going on. We've been in communication with the International Astronomical Union. The issue is just not quite resolved yet. I'm hoping we'll have an announcement very soon. But nevertheless, we're going to have an awful lot of names left over. That list of 30,000 write-ins is still a resource that I can pull upon. And I have an idea about how to use it, because this is what Pluto looks like today. We know there's some fuzzy blotches, but this is the best we can possibly see Pluto through the Hubble telescope. In 2015, New Horizons will get there, and Pluto is going to change. It's going to look more like that. And at that point, we have the option of naming features on the surface of Pluto. And so if we see a big flat area, it just seems perfect that maybe its name should be the Elysian Field. It's just got to be. My sentimental favorite names was from the great story about Orpheus and Eurydice, so maybe 2 nearby features can be used for that. Of course, if there's a big mountain somewhere on Pluto, it's got to be called Mount Sisyphus. It's just got to be. We are no longer confined to names from Greek and Roman mythology, however. So for example, Clyde Tombaugh was the great astronomer who discovered Pluto. Carl Sagan, we all remember. It would be very appropriate to name features on Pluto after them. We can also bring in literature from other parts of the world and from other genres. So for example, a popular write-in was Cthulhu from the short stories of H.P. Lovecraft. Hoth was the ice planet from the second Star Wars movie. And finally, all those fans of Walt Disney, someday they may be able to get a chance to name the happiest place on Pluto. So, thank you very much.
Mark, we're so grateful to you and to SETI for coming back once again.
Thanks.
Our great friends, beginning with Frank. Please pass on our regards.
And Jill?
Jill, yes.
Yes.
SETI, check it out, the search for
SETI.org.
extraterrestrial intelligence. While all this is going on, the search carries on, does it not?
Does. Yes, it does.
Right. Let's have our picture.
Idea City is a place where ideas come face to face to inspire and give us hope. At this time, our planet needs it most. Idea City is a place. Everybody sing. Where ideas come face to face to inspire and give us hope. At this time, our planet needs it most. Idea City, gotta bring our ideas to Idea City. Where ideas come face to face.